Hi everyone. We're going to take a look at using Microsoft Excel to do the standard deviation and kind of build out the standard deviation formula as we go. If you recall, we have 51 pieces of data here that are talking about the percent of people that are born outside of the state. So in West Virginia, 1.2% of the population is born outside of that the state of Virginia. So that is our X. That's what we're working on. And I can't put the X bar in here. Well, I probably could, but I just wrote X bar. Remember, X bar is our average. So the first thing I just want the average. And just to kind of review a couple of the terms and things, when I work with this, here is equals the average. And I don't want the parenthesis first. Average of, I'm just going to do the average of everything in column B. So B colon B. I could also do B2 to B51 because that's the specific area where that data is, but it does a good job of not counting that first row that is the header. So I want the average of column B, which is about 8.4. So keep that in mind. And remember that when we're working with this idea of standard deviation, we're building a formula that wants to work with the variance. It wants to work with this idea of having the sum of all of the differences, how far away something is from the actual mean. It wants all of those differences squared like this, and we want to take all of those things and we want to divide it. Now, most people would say it's like the average distance from the mean, which is good, and they would say, well, if you're doing that, you're going to divide it by how many there are. And remember, we're dividing it by n minus 1. So we're taking the sum of all of these things squared, I forgot the squared, and we are dividing it by n minus 1. And again, that n minus 1 gives us a little bit more room for error. That's the variance, and then we are taking the square root of that. So this is our formula for the standard deviation. So standard deviation is the sum of all of the differences between the mean and each number squared divided by n minus 1. So that's the normal standard deviation. We're going to use the software to kind of build that out, and then we'll also look at how we can just find it with Excel as well. So first thing, and the reason we do this is a few tricks in here. I want to find the average of column B minus the cell right next to me. So I could just, I'll backspace over there, could just click that. You know, same thing with when I was doing the average, I could just click column B. I do all of column B, and the cool thing about this is this B2 here, when I use this little handlebar and drag down this bottom corner, notice how it turned into a plus sign, it changes that for each one of these because it's relative. This is actually saying I want the average of the column next to me minus B6. All right. Now, the reason I point that out is if I move this over, let's say I grab this and drag it this way, way different number. Look what it did. It did the average of the column next to me minus C6. Relative, that's exactly the same as this one. Left, and the whole column left of me, and then that, and this one's the whole column left of me minus this. But that's the idea of being relative in there. So that's a relative position. And so I'm going to grab this and drag it down. So for every single one of these entries, did the average of the column next to me minus the number next to me. All right, I really want all that squared. So I'm going to do, in parentheses this time, the average of column B minus that, and then I'm going to put a squared at the end of it. All right. I could also have just done equals the number right next to me, C3 squared. Notice it just says, hey, take the number that you just got next to me and square it. Either way, you're going to end up with the same results. One's a little bit simpler, kind of a cheating method through it. Nice thing is, you remember as you're working with distance formulas and things like that, we square it. We got rid of all of the negatives here, which is important. So we are now going to find the average of all of these differences. So the next thing we do is we add all these up. Well, the sum just wants all of column D. So I'm just doing the sum of column D. Add them all up. Just get one number. I don't need to do it over and over again. I want that number divided by n minus 1. So I could just say equals the sum of column D divided by 50. Remember, we could get into counting formulas, things later, but for right now, I know there's 51 pieces of data over here. I'm dividing by 50 because that's going to keep a bigger chunk or a big number for the standard deviation. Gives me a little bit more wiggle room for error. Divide by 50. So there is that. And then to do square roots in Excel, we just do SQRT of the number next to me. Boom, I have it. I could also do the number raised to the 1/2 power. Remember, that's the same as the square root. And then finally, the way that we typically will do this in Excel and Google Sheets is say, I want to find the standard deviation of something. It's STDEV. There's a bunch of them here, and they're all for different things. Some of them are standard deviation of a sample, standard deviation of a population. We just want the regular standard deviation formula, and I believe that's actually now been replaced with the .s here. Well, let's just check that out. I think it's the .s. They replaced that on me. I use Google Sheets a little bit more. Whoops. So equals stdev.s for the sample, and we want all of these numbers. And there we go. I'll show you again the idea if I did it for the population, standard deviation.p, and did all of the, whoops, keep forgetting to put in the parentheses. For the population of all of these numbers, that's a little bit smaller. So that idea that we're doing the n-1, we're giving ourselves a little bit of room for error. And it's usually, we're very rarely using things with an entire population. Well, most of the time we're working with sample size. So that's the unbiased way of going through there as opposed to the biased one. So that's the formula that we're using here. All right, so now I just want to show you the graph of this, and instead of just using the regular one, I'm going to define bins. I want bins of 5, just to kind of keep it easier to see. So I've got 0 to 30. That's going to be the bins for my standard or for my histogram plot. So I'm going to go over to data, data analysis, histogram. Say okay. I want input range there. I want bin range to be these numbers. So it goes from 0 to 30. I want the output range to be, we're just going to put the graph right here and chart the output and say, okay. So there I've got bins of 0 to 30. It counts up how many are in each one. So that's perfect. And let's grab this chart over here and throw this up a little bit. All right, so here's my chart. This is my data. All right, according to this data, my standard or my average is actually inside there. So if I kind of put this out here, like here's in red pen here. All right, so here is the chart for this, and just because I've never quite liked the way Microsoft does this, here's 0 and here's 5 and here's 10 and 15 and 20 and 25. That's where those are, and so really there's nothing there. Really for this one, you kind of have this chart that goes all the way up. Like that's your 5s. There's 5 to 10. 10 to 15. It just helps visualize, like here's where 0 or here's where 5 is at, here's where 10 is at, 15, 20, 25, and 30. That's the way the histogram should be. It should be equal. The weights should be all the way across. Now, on top of that, our average X bar is 8.4. That's really pretty close to right about here. So here's our average of 8.4. Our standard deviation, we said, was about 6. So a standard deviation means I'm going to go one standard deviation each direction. So here's my first standard deviation, means I'm going 6 each direction. So 8.4 minus that, I'm going to be over here at about 2.4. All right. One standard deviation to the right puts me over here at about 12 or 14.4, excuse me. So really close to that. So we're basically breaking this chart up. If I go a second standard deviation, I'm just going 6 again to the right. So all of a sudden I'm at 20.4. And then one more standard deviation puts me at about 26.4. So the idea in that standard deviation is we're kind of breaking this out. I could go 6 each way. So here is my mean. Then we've got -1 standard deviation, and we have +1 standard deviation, and 2 standard deviations, and 3 standard deviations. That's what we're going with this. The other idea is we took a look at kind of that bell graph before. We're really saying that how much space is there in each one of these. So the idea really ends up being, and let me erase some of this junk up here. Didn't mean to erase that standard deviation there. So I'll throw that one back in here. That one was at about 14.4. The idea is that in the first 2 standard deviations, you have approximately 68% of your data. All right, and then it changes from that, but that's where we're focusing on right now. I'm just going to kind of show you. And so let's take a look at how this data matches. Even though it's not a standard bell curve, and it's very much skewed to the right here, not symmetrical at all, take a look at this data. So I'm going to stop this inking, and I'm going to jump over here and say from Kentucky all the way down to Washington, that's 32 entries there. 32 entries, and make sure I counted that right. 39 minus 7, so the 32 entries here. Those 32 entries are supposedly going to be in this area from 2.4 to 14.4. And just as an idea, 32 divided by 51, the percent, we end up, that's 62% of the data. That matches really closely to what we expected. All right. We also find out that one of the very extreme outliers is the one way out of this 26.4. That's really about 0.15% of the data is out here on this very, very far end. And we're talking like 0.15. So 15 out of 1,000 would be over there. And that's where California finds itself, way out here on the far end. Same thing with New York. New York and California. New York's still within here, and so is New Jersey, but California is on that far outside there. We also don't have anything over on this side. So notice this graph's not symmetric. We'll talk about standard deviation and whether or not it's appropriate at all times to use the standard deviation and how it gets used. Usually in data that's skewed, we tend to find that the 5-number summary and a box plot would be a little bit more appropriate for that data.